Hi students, welcome to this video lesson. Today we are going to see set language. In this pictorial representation, we shall come to know the set of fruits, the set of home appliances. In our daily life, we often deal with collection of objects like books, stamps, coins, etc. Set language is a mathematical way of representing a collection of objects. A set is a well-defined collection of objects. Well-defined collection of objects means the given specific object must be possible for us to decide whether the object in an element the given collection or not. The examples are the collection of all planets in our universe, the collection of states in India, the collection of vowels in English alphabets, that is A, E, I, O, U, the collection of first five natural numbers 1, 2, 3, 4, 5. X belongs to S means X is an element of set S. And also X does not belongs to S means X is not an element of set S. Some important sets we have seen in our previous classes. For the set of natural numbers, the symbol N. The set of integers are Z. The set of all positive integers Z plus. The set of all rational numbers Q. Set of all positive rational numbers Q plus. And the set of all real numbers R. The set of all positive real numbers R plus. The set of all complex numbers C. Here I would like to tell you some notes regarding the set language. In the first point you can see the set 1, 2, 3 is a set containing 1, 2 and 3. In the second point, the set containing 1, 1, 2, 3, 3, which is equal to set 1, 2, 3 because repetition is irrelevant. Also, in the third point, 1, 2, 3, 3, 2, 1 is equal because since the sets are unordered. Also, 1, 2, 3 up to 100. Where ellipsis, this dot line indicates that the list continue in the obvious way. This ellipsis may also be used where sets have infinitely many members. Thus, the set of positive even numbers can be written as 2, 4, 6, 8. The representation of a set can be done using two ways or the three ways. The first one is roster or tabular form. The second one is descriptive form and the third one is set builder notation. First we shall see that roster form, that is tabular form. It is nothing a set described by listing of elements separated by commas within the braces, the curly braces. The next one, set builder form. Set is described by a characterizing property P of X of its element X. Here, set X such that P of X holds or X such that P of X holds. The symbol slash or colon is read as such that set of vowels of English. Roster form, that is A equal to A, A, E, I, O, U. Set builder form can be written as A equal to set X such that X is an English vowel. In the second example, set of first 10 natural numbers. We can write it in the roster form A equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the set builder form can be written as A equal to X such that X belongs to N and 1 less than or equal to X less than or equal to 10. In the same way, this third and fourth example can be written as roster form and set builder form. Descriptive form, set builder form, roster form. Descriptive form. This is simply a description form and the set builder form is build up of description and with the symbols. The roster form can be written within the braces. The next we can see types of sets. There are 12 types of sets. Empty set, singleton set, finite set, infinite set, equal sets, equivalent sets, universal set, subset, proper subset, superset, proper superset, power set. empty set. A set containing no element is called an empty set. It is also known as null set or void set. It is denoted by empty curly braces and with pi. Here the example is given. A set A equal to x belongs to R real numbers and x square equal to minus 10. If we square the number, we'll get a positive number. There is no chance of getting negative number. So this kind of number or this kind of set will not be available in this set. So therefore it is equal to pi. The next one, B equal to set of immortal man. Here all men are mortal. There is no man in the earth as a called immortal. So the next one, singleton set. The word itself clearly gives an understanding that a set having exactly one element is called singleton set. In the pictorial representation you can see in the circle there is an element 2 and another element 5 in each set. The next one we can see about finite set and infinite set. Finite set. A set consisting of a finite number of elements is called a finite set. What is infinite set? A set which is not infinite set, that is set consisting of infinite number of elements. You can easily remember a finite set means it has an end. Infinite set means it has no end. Look at the example for the finite set 1, 2, 4, 6. It is a finite set because it has 4 elements. The set of months is a finite set because it has 12 elements. And looking at this example of infinite set, the set of all straight line in a given plane. The second one, the set of all natural numbers, which has no end. The set of real numbers between 1 and 2, which is infinite to define. The next we can see cardinal number of a set. The number of elements in a finite set is called cardinal number. I repeat, the number of elements in a finite set is called order of the set. It is referred as a cardinality of the set A and as denoted by n of A. For example, if A equal to 1, 2, 3, 4, 5, then the number of a set or the order of the set is equal to 5 or order of A equal to 5. If S equal to 3, 3, 3, 3, 3, then the modulus S equal to 1. If S equal to pi, then modulus S equal to 0. Set of sets. A set S having all its elements as sets is called set of sets. For example, S equal to 1, 2, 2, 4, 3, 5, 9. But look at the set S equal to 1, 2 and the number is without the braces and 3, 5, 9, which is not a set of sets because the element 4 is not a set. And we shall see equivalent and equal sets. Equivalent sets. Two finite sets A and B are equivalent if their cardinal number is same. If their cardinal number is same. That is n of A equal to n of B, which means number of elements of set A equal to number of elements of set B must be equal. For example, look at down A equal to 4, 5, 6. There are 3 elements. And look at the set B equal to A, B, C. Here also 3 elements, which means set A equivalent to set B. That is A equivalent B. And the next definition, equal sets. Two sets A and B are said to be equal if every element of A must be or should be a member of B and every element of B must be a member of A or should be a member of A, which means here you can see the example A equal to 4, 5, 6 and C equal to 6, 5, 4 are equal. That is set A equal to C. Here I have enclosed some symbols for the set theory, which means in the set language we will use the following symbols. You can identify this and learn it for yourself. Some of the set notation I would like to introduce for this lesson. This symbol union, the first one is subset, The third one is intersection and the fourth one is element. In the down you can see null or empty set, not a subset, not an element. Here you can find subset, not a subset. The next we can see the type of set, that is a subset. A set A is said to be a subset of set B, that can be written as A subset of B if each element of A is also an element of B. A subset of B if element of X belongs to A, which means element of X can also belongs to B. That is an example. Let A equal to 2, 4, 6, 8 and B equal to 2, 4, 6, 8 and 10, 12. Here you can see the elements of A will be containing in set B. Therefore, B is a superset of A and B contains A. In a reverse way, we can tell it. And we can see proper subset. A set A is said to be a proper subset of set B if every element of A is an element of B and B has at least one element which is not an element of A. That means A is a proper subset. A is a proper subset of B. A is a subset of B and A will not be equal to B. A subset which is not proper is called improper subset. For example, let A equal to set 1, 2, 3 and B equal to set 2, 3, 4, 1, 5. Then A is a proper subset of B. Thus, if A is a proper subset of B, then there exists an element X belongs to B such that X does not belongs to A. For example, set 1 proper subset of set 1, 2, 3. But set 1, 4 is improper subset to the set 1, 2, 3. Here is also some more example and you can find it. Power set. The set of all subsets of a given set A is said to be the power set of A and is denoted by P of A. That is, power of A equal to S such that S subset of A, which gives S belongs to power of A, that is S subset of A. Also, pi belongs to power of A and a set A belongs to power of A for all sets A. With the description form, here I would like to tell you in words, a power set of a infinite set with the n elements has 2 power n elements. For example, if A equal to A, B, C, then the power of a set is P of A equal to, the first one will be empty set and the separate sets are set A, set B, set C and the joining sets A, B, A, C, B, C and finally A, B, C. These are called as a power set. The pictorial representation will give you some more clearance for our understanding. Finally, we can see the set universal set. Any set which is superset of all the sets under the consideration is called the universal set and is denoted by omega or universal set. For example, when we are using sets containing natural numbers, then n is the universal set. Here, look at the pictorial representation of the intersection of sets and the disjoint sets. Or you can tell union of sets and the disjoint sets under the universal set. So students, recall what we have learned today and revise it and learn it clearly. Thank you students.